Welcome to School of Physics with Peter Fodu, and this is the section on the basics of physics. Today we are going to be starting with what I call terminologies in physics. I'd love to add a particular word to that, basic terminologies in physics. And so that's what we'll be discussing today. I'll start with the part one of this, and that has to do with measurement and units. A basic terminology here is length. And length refers to, trying to just get the distances between points. How far, talk about how far things are. The intervals in terms of, distance, that refers back to distance. The interval in terms of distance, or the space between 2 points. 2 points. These are, I'm abbreviating here, this represents between. So please, you can take note of some of the shorthand I will be using. This represents between. Now, when we speak of length, to calculate some of these lengths, distance, how far 2 points are, maybe on a material or whatever, the space between two things, distances, we use instruments, we utilize measuring tools or apparatus, such as this is where we're now bringing the discussion of meter rule, bringing vernier calipers, talk about the micrometer, screw gauge. Later on in the future, when we are dealing with measurement properly, we can discuss these things in details, but this is just basic knowledge. So these are some basic measuring apparatus. When we speak of length too, we have the discussion of units. Talk about units. Units of this measuring instrument, the units of measuring instruments. That comes into discussion. So each of them, they have their units. Every measuring instrument has its unit. They have their units of calibration. Let me put it there, calibration. The units in which they are calibrated. So straight up, I won't waste time. We'll go to the next terminology. We speak of mass. Mass is another terminology. This time around, mass, we popularly know that the amount of matter refers to the amount of matter in a body. This is just basic knowledge. So when we talk about the concept of mass, we talk about the unit of mass. Yeah, when I say unit of measuring instrument, I mean with respect to length. So I'm talking about like the unit of length because we just spoke about length. Now here we talk about the unit of mass. Don't worry, we'll talk about that. Mass has a unit. The instruments used to measure mass, we can talk about the beam balance. Beam balance. Talk about the triple beam. The beam balance is the triple beam balance. We can talk about the electrical balance. The electrical balance. We have electronic, or let me rather still call that electronic balance. Please, this is a very, very really I'll call it a realistic class. So I will be, if I make a mistake, I'll correct myself, and I want you to be able to relate with the terminologies, with the ideas, and catch them fast. So the electronic balance, as we go further, we'll look into more balances as we see them. We have chemical balance. Let me just write that down. Chemical balance. Keep that in mind. So the next terminology to talk about is time. Time. Time has its units. I'm going to speak about the unit of time. I'm going to talk about the unit of time. So the fact I'm talking about basic terminologies in physics is just like me giving you some rough content that we're going to build on. So I'm going to talk about, so you have to follow me in this video series and the playlist because it's School of Physics, Peter Fodo. And so we're going to talk about the unit of time. We're going to talk about time being interval between two events. You know, we talked about length being like interval between 2 points, like distance. But time is interval between two events. I'm going to be very, very free and relatable and realistic in this class. Interval between two events, time. Then we'll talk about time measuring devices. Time measuring devices. We'll talk about and under that we'll talk about the stopwatches. We'll talk about the stop clocks. Talk about the stop clocks. Talk about simple pendulum. Yeah, or pendulum clocks. There's stuff like the ticker timers. So pay attention to the most important things. Fundamental. We also talk about, there's something called, when you talk about physics, we talk about fundamental physical quantities and the fundamental units. We are going to talk about that. Quantities and fundamental units. Yeah. So, and under this, we'll talk about meters, talk about kilogram, like the basic ones. I'll talk about seconds. So let's quickly delve in. We'll continue in our next video. We'll talk about the content we want to discuss. Then we'll look into discussion. Let's discuss now. Discussion. We said we're going to talk about measurement and units, and then we'll delve in. Let's delve in now. So I hope you're ready with your pen or your paper, or you're listening with rapt attention rather. Speaking of measurement of length, measurement of length. We can measure length by using the meter rule. I'm going to start with talking about the meter rule. Pay attention because we'll just highlight the most important points. When talking about the meter rule, we measure length in the meter rule. We measure length to 2 decimal places. So we'll do that in centimeters. Measure length to 2 decimal places. I will do that in centimeters. Speaking of the meter rule still, we say we measure length to the accuracy of 1 millimeter or 0.1 centimeter. That is the smallest graduation, or I can call that calibration on the meter rule. That's the smallest calibration on the meter rule. So keep that in mind. And when we talk about that, the meter rule looks something like this. It looks something like this. And when you see it, you will discover that there is a point. You see 1, you see 2, you see 3, you see 4, you see 5, you see 6, you see 7. But you discover that in between, you call this 1.1. 1.2 up to 1.5, you now have 0.6, 0.7, 0.8, 0.9, then 2. So that 1.1, the idea behind that 1.1 is that the smallest one you have there is 0.1. So that's why immediately after 1, that small thing you have will give you 1.1. It's because the smallest one there, the smallest calibration of the meter rule is 0.1. I hope you get the idea. Let's now move to another point that says the uncertainty. And there's to say it, or let's say the reading accuracy, let's put it that way, or reading accuracy of the meter rule is 0.5. No, let me put it like this. Okay, let's say 0.5 millimeter or 0.05 centimeter. The meaning of that is that every reading you take, this corresponds with the first point that says you should measure to 2 decimal places in centimeter. If you look at it, the uncertainty has that same characteristics. So the uncertainty or the reading accuracy is 0.05. So every reading you take, every measurement you take, just keep this in mind as a rule. Every measurement you take is going to be the measurement, let's say the measurement plus or minus 0.05 centimeter. So that corresponds with the fact that all your measurements should be written in 2 decimal places. You can't just write the measurement as 20. No, it's better to write it as 20.00 centimeters so that you can add plus or minus 0.05 centimeter. These 2 parts correspond. Thank you. It's just, those are just like, that's why I call it basics of physics. Those are just principal things. And then the meter rule, let's say conventionally, that's when if that's too big English for high school student or basic learners of physics, conventionally means like what we regularly agree, generally agreed to measure. It's used to measure bigger length. I mean, like in the lab, the longer length. And this relative actually measure bigger or longer length. Let me not use the word bigger. Let's be more very, very physical. Let's stick strictly to the principles. So measure longer lengths. Okay, that's the idea. And you will discover that this is relative because when we talk about some other measuring devices, like take for instance, let me go straight to the vernier caliper now. Vernier caliper. The vernier caliper has 2 scales, and you discover that it measures far much less or smaller length than the meter rule. It has 2 scales. That's the main scale and the vernier scale. The main scale reads like a meter rule, reads like the meter rule, just like the principles of the meter rule, it just follows that. Why the vernier scale? The vernier scale, you add the decimal portion, add the specific value divided by, let me see, divided by 100 to the main scale. Okay, so on the vernier caliper, yeah, but it still works with a rule. Let me show you that rule, how it works. So if you have the main scale now, the vernier scale, this is it. This is the main scale. This is the vernier scale. Now, if you have, say, if you have 1 here and you measured something, you have this, you have Let me adjust that so we can be more realistic. Say you have 1, 2, 3, 4, 5. So let me raise this small to represent this is 1. Then you have 6, 7, 8, 9. Then you have 2. Let's just keep it realistic. Now, on the venial, on the main scale, it continues to read like a meter row, like every other thing continues from here. But on the venial scale, you have about 9 parts. So you are going to have 9 parts that look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So now, and you will discover that of all the 9, there will be one. If you look at this part, it corresponds. There will be one that strikes the main scale exactly. You get it? So there will be one that strikes the main scale exactly. Once you discover that particular one, that is your reading. But how do you now read the main scale? The main scale, you read that as the last reading before the venial scale is your result here. The last reading before the venial scale. Before the venial scale is your result. Is your result. So my reading for main scale here is going to be 1.20 centimeter. That's very clear. Why? Because this is 1, 1.1, 1.2, then the venial scale starts. So this is the last reading before the venial scale, giving me 1.20 centimeter. Now, when we talk of the venial scale now, in order to read the venial scale, I said something which I wrote here. I said, okay, when I said add here, I mean like, you see it here, we're about to add in order to get the total. So that's what I meant by add. Now, but look at the other part of the statement. The specific value divided by 100. So let's go to that. If you look at it, what I meant by specific value is that when you start counting from the first one, 1, 2, 3, 4. Look at, and the specific value, we are referring to the one that corresponds. You discover that, you discover that this is the only one that corresponds, like matches the main scale. So that specific value is 1, 2, 3, 4. We say that value is 4. Then divide that value by 100. That will write it as 0.04. Then when you add it, the answer for this venial caliper reading is 1.24. I believe that if you rehearse that a number of times, you should be fine with mastering it. So let's still talk more about the venial caliper. It is used to measure for internal and external diameters. This is really when you start, doing some practical physics, you discover it's very instrumental for small length, internal and external diameters. External diameters of round objects. It measures to accuracy greater than 1 millimeter. That's a point, but I would say, let's say it this way. It measures 2 decimal places in centimeter. So let's also state its accuracy. Its measurement should be plus or minus 0.01 centimeter. That's what we use here. So 0.01 centimeter is what we call the accuracy. So and then so it measures, we also saw that it measures smaller length than the meter rule. So as in the case of the meter rule, we had plus or minus 0.05 centimeter, right? Can always backtrack. But in this case, we have smaller. Can pick. It is more precise. More precise. Of course, this is smaller than this. So just move on from that discussion. Just know that one is more precise than the other. And one of them has more uncertainty, the other one has less uncertainty. This guy with more, this is more uncertainty. So since this one is more precise, it has less uncertainty. That's just a mental discussion. Let's move on. We really have a lot to discuss. Let's move on to the micrometer screw gauge. So I will discuss vernier caliper, micrometer screw gauge. Micrometer screw gauge, this time around, we've been talking about 2 decimal places all this while, but this stranger here, sorry, I'll be very relatable. The stranger measures to 3 decimal places. Let's find how interesting this guy can be. In centimeter. It has 2 scales, just like the vernier caliper. Has 2 scales, just like the vernier caliper as well. 2 scales, like the vernier caliper. And I'm just going to draw what it looks like. It looks something like this. I mean, the part where you see the measurement, you see something of this form, this, and then you discover that you have this, this. Let me be very realistic. So you add one here, and then let me add one here, another one here. So I'm going to show you how this works now. Let me put, in case I put maybe 10 here. And then I can put one here. I can put if I put 15 here and I put 20 here. So this scaling is according, you have to put and bring a mental picture into it. And in case I put, so let me redraw this. In case I put 1 here and I put 3 here, you have to bring a mental picture into it. So it tells us something, that this particular guy is scaled such that you have 1, 1.5, 2, 2.5, 3, 3.5, 4. You see that? That's how the micrometer screw gauge works. So, and the last reading, so that's the main scale. I will read that as the main scale. I'm going to read that as 4.000 centimeter. So here, the main scale, for the main scale, you read like the meter rule too. Read, I won't say read like meter rule, read according to scale trend. To scale trend. That's what I'll say. but express in 3 decimal places. So let's quickly not waste time. We are physicists, so we have a lot to cover, so we shouldn't waste time. So this guy, the Venner scale now, I want to try and read that according to scale. This looks like 10, then 15, then 20. It means like 10, then the next one should be 11, next one should be 12, the next one should be 13, next one should be 14. Then we have 15, we have 16, and then it goes on and on. But what matters to us is the point that corresponds with this line, the line of the main scale. And that appears to be 15. So, and the next thing to do is to divide 15 by 1000. In this case, we are going to divide by 1000 because we are expressing to 3 decimal places. In the case of vernier caliper, we divided by 100 because we are expressing two. See it here, see that terminal divided by 100 because we are expressing in two decimal places. But now we are divided by 1000. So once we do that, we have 0.015 centimeters, and that gives us, this is the vernier scale, and that gives us a final reading of 4.015 centimeter. You discover that the measurements here now, they have an uncertainty of 3 decimal places, and I can write that as this. So, and then that means they are much more precise, and so they are much more accurate because they have very less uncertainty, very low, very low, very low uncertainty. So they are very much more precise, and so they can pick the slightest of measurements, the in-betweens, and be more accurate. So this gives us something wonderful. So that's discussion of devices, the measuring instruments for now. Move further to state that length, some quantities related to length, we'll see later. Area is related to length, volume, all these guys related to length. This is basic physics. Let's go on to the next discussion. Mass, measurement of mass. Quantity of matter in the body. So the measuring instrument, we said the beam balance. So in the beam balance, we can have two divisions. We can have a chemical beam balance and a physical beam balance. So we can also have a Borchardt balance. Some of these things as we speak, they might be very outdated. And that's why I will talk of the last one, electronic balance. Just place your stuff on it and to give you a reading. Electronic balance. Electronic balance. I think in some labs, they still use the triple beam balance. Still use the triple beam balance. It's interesting. Triple beam. And that should correlate with the physical. Well, that's basic knowledge. Let's go straight to measurement of the discussion on mass. Quickly brings us to something called weight and force in basic physics, because people sometimes misconstrue weight as mass. No, they are not the same. Mass, amount of matter. Weight is a force, specifically related to the gravitational force. That's why we have weight equals to mass times acceleration due to gravity. So it produces a gravitational force. So the acceleration in this case now is due to gravity. This is the definition of width. In physics, most of the time, we don't define with a lot of write-ups. That's another basic thing you must understand. If I, in an exam, I'm able to deliver this formula and use all these notations, I score full points, except the examiner doesn't know what he's doing. And maybe he demands something special that I should use words, fine. But physics is very straightforward. So when we are measuring weight, we use what we call spring balance. And this guy works based on Hooke's law. Just keep that in mind as theory. We will get to discover this as we go on in the School of Physics. He uses a principle. We use different principles in physics. We use a principle called Hooke's law, the spring balance. Let's quickly go to the measurement of time. Measurement of time. So like I highlighted before, we have the pendulum clock, and this guy simply works on the principle of a simple pendulum period. Period is given by the formula, the time for each oscillation over the number of oscillations. The time for each oscillation, or let me put it like that, no, this is the total time of oscillation, of the entire oscillation. The time required for all the oscillations to take place, divided by the number of oscillations that has taken place. This will now give us you get it. So this is time for entire oscillation. And the number of oscillations that has taken place. So this is what I was now referring to as the time for each oscillation. Because you see, it's just like a unit. When you have a lot of things, you now divide by the number. It's just like an average. Time for each oscillation. So and when we go further into physics, you'll discover that this relates to something like 2 pi over which you just keep this as theory. I don't want to bother you a lot. The same period relates to this. So, but that's the principle on which the pendulum clock works. We have stopwatches. Like these are very common because they're electronic. Now we have electronic ones, electronic clocks, stopwatches. And then the ticker timer, outdated, but works more on the principle of frequency. Ticker timer. So works on the principle of period being equal to 1 over frequency. So the more number of dots you see, the space between them, how spaced out they are. So if you see this, if you see a body that shows you this, and the next one is here, next one is here, while you have another body occupying the same distance. So another body from here to here, another body moves between like this. Which of them is faster? Oh my God. This guy seems to be faster, but can we confirm? Like, just based on logic, it seems to be faster. This guy seems to be taking a lot of steps or something. But let's see, because this guy takes 3 dots. Let's see, the length of the tape measures the distance. Number of dots is a measure of time. Yeah. So you have let's say in 1 second. Let's say this interval, 2 of them in 1 second, they make this number of dots. We can calculate So let me bring the idea so that you can understand it. I'm not going to. So the ticker timer uses these dots to measure time. Dots as measure of time. So let me take an example. This is, let's establish that. I will be using examples to establish things. Like I said initially, it measures based on frequency. So it will give you frequency. Say, okay, a body makes 50 dots in 1 second. Calculate its period. So what we simply do is that the period will be equal to number of, we can say when you say 50 dots in 1 second, that's literally telling you that the frequency is 50. But my question is, what if it's in 2 seconds? It will now be 2 over 50. What gave us frequency as 50 is the fact that t is equal to 1 over f. And so we can easily say 1 over 50. But what if, okay, let me do something. Let's just focus on this particular question. Let's not digress. I'm going to be as realistic as possible. So the fact that I said 50 dots in 1 second means frequency is 50. So I can easily say this is 1 over frequency, which is equal to 1 over 50. And so you can always get your stuff at 0.02, rather 0.02 seconds. Now, in the case of, let's now take a case of 50 dots in 2 seconds. How do we find the period? Period is going to be t equal to, remember that t has its own formula, t over n is equal to 1 over f. So we can even deduce the frequency from the period. So let's find the period first. Period is, we are given this 2 seconds. The number of dots, 50. That's going to give us, I can say this is going to be 0.04 now. And so if this is equal to the frequency, it means frequency is now 1 over 0.04, which is simply 50 over 2, and which is 25 hertz. So we can see clearly that frequency now has a formula of n over t. So we have easily established that t period, t over n, frequency n over t. How did I look at that big picture? 50 dots in 2 seconds, and the frequency is 25 hertz. That means we just did 50 divided by 2. Let's quickly move forward. Let's not waste time. And we're going to physical quantities. Physical quantities now in physics. Fundamental input, fundamental input. Let me enlarge this. Fundamental physical quantities. Let me quickly go back and have a reflection. On what we said we're going to discuss. Said we're going to discuss mass, we are in physical quantities and fundamental unit. Yeah, before we went to discussion. So this is our last discussion for this section of basics of physics. This is our last discussion. Physical fundamental quantities and fundamental unit. Now, next and subsequent videos will continue to establish discussions and continue to grow in the School of Physics. So let's discuss this fundamental physical quantities and fundamental units. Let's go back to where we're fundamental physical quantities and fundamental units. So I will say the fundamental physical quantities, let me just list them out. Quantities, and I will list their corresponding units. The corresponding units here. So the quantities, I'll say length, and the unit is meters. And I'm going to put that as small m. I'll say mass. I'll say the unit is kilogram. I'm going to put that as kg. I'll say time. And the unit is seconds. I'm going to put that at S. I'll say temperature. And the unit of that is Kelvin. I'm going to put that as a K, but this time a capital K. So I'll say current. We have current. I'm going to put that as ampere, the unit. And this time I have a capital A. Another fundamental unit is light intensity. Light intensity. I'll say the unit of that is candela. Now I'll put that as a C and then a small d, C, D. Yeah, so keep that in mind. Light intensity, length, mass, time, temperature, current, light intensity. Yeah. And then maybe amount of substance is what I'll just add that one. Amount of substance. Substance. I mean, I can say that is a mole. Let me just put MOL there. Amount of substance. Okay. So these guys, I'll establish them as the fundamental guys. Any other ones that we can, so these guys are, I would define them as building blocks for other quantities in physics. So the derived quantities are now what we call derived. Oh, we have not yet talked about derived, sorry. So we are still in fundamental quantities and their units, right? So that's what we said we were going to talk about. So in our subsequent videos, we'll try to establish some other points for basic physics. Yeah, so this concludes this particular video. And thank you for listening up to this point. Make sure to subscribe. And more importantly, learn physics. Physics is cool. Knowledge is power. And I wish you well as you journey through life. I remain Peter Ofodu, your tutor and your friend in the School of Physics with Peter Ofodu. See you in the next video. Thank you.